At one of NGI's laboratory, researchers have done their best to mimic the conditions that are 384,400 kilometers away from the Earth, the conditions on the Moon. By studying 10,000 particles from the Apollo expeditions, they gather valuable information for the first Moon expeditions in 50 years, the Artemis. This time, the aim is to build a habitable base on the Moon with permanent constructions and, for instance, a system for food production. After all, there are no lunar food delivery or takeaway services available for the future astronauts. So, what are the conditions on the Moon like? How do materials like a grain of lunar soil behave? Is there, for instance, sufficient minerals in the lunar soil to grow food? And what about water? My name is Liv Bjergene, and you are listening to NGI's podcast Med blikket mot bakken. This time the episode will be in English, simply because the researchers I have in studio today, senior geophysicist Dylan Mikesell and senior researcher Luke Griffiths, who both work here at NGI, speak English. Luke and Dylan, welcome.
Thank you for having us.
Images that I think most of us have in mind when we talk about moon expeditions are the black and white clips of Neil Armstrong when he on July 21, 1969, took humanity's first steps on the moon. So, Dylan and Luke, can you give us a description of what conditions he and the rest of the crew on the Apollo 11 mission actually met?
Yeah, I can take that one or start. Thanks for the question, Liv. I think the thing that comes to mind for most people when they think about the moon and what it's like up there is that there's no atmosphere. So that means there's no oxygen to breathe. And that's why we've always seen these images of astronauts in spacesuits. The other thing that people might think about is that it doesn't have any liquid water. So the surface is quite different from here on Earth. There's no air, which means there's no weather, and there's no liquid water, which means that the particles that make up this dirt where the astronauts landed is going to be behaving quite differently than most particles here on Earth because we just have water everywhere. I think another thing to think about is just the type of the material that the surface is made out of. It was completely foreign. The astronauts went and practiced in places like Craters of the Moon National Park or Monument in the U.S. To try to get an understanding of what it was going to be like to try to move around in their suits on the surface of this foreign object. So quite different from what we have here on Earth is what I would say. And that's sort of what they got. I don't know if you want to add anything else, Luke.
Yeah, I mean, just looking at the images, it looks like this really nice kind of fluffy texture, but it's actually these super sharp particles which are really abrasive and it's causing lots of problems. So yeah, it's very different to what we have on Earth. Yeah, I think as well. I mean, the temperatures we have on the moon are extreme, from like 120 C during the day to minus like 180 during the night, depending on where you are. 120. Yeah, it's really quite extreme. And so you can imagine any equipment or anything, or just being on the moon yourself, you has to be able to tolerate these temperatures, and like thermal stresses and things are going to be huge. I mean, to the point, like we have these moonquakes, which may have like thermal origin as well. So it's, temperature plays a huge role. And it's kind of so extreme as well because you have these long nights. So it's like 14 Earth days for night and day. And so you can imagine there's time for it to cool down and heat up. So I think for those ones as well, like when it's that cold during these long nights, it's really important that the equipment and things can work, and for the satellite communications and things, that we can kind of survive the night. And this is a big ongoing effort for this to do this. Yeah,
it sounds quite scary.
It does. Yeah, I mean, one of these it's really cool. A website called Apollo in Real Time. It's like a group of it groups together the Apollo 11, 13, and 17 mission material. So there's like film footage, there's the audio, there's the transcripts, all the communications between Earth and the astronauts. And you can just see them kind of going about their kind of daily kind of chores to collect samples, to repair equipment and things. And everything is a struggle. Like they have their huge suits on, they're falling over, they're trying to hammer in sample tubes and rake up dust and things, and it's just getting everywhere. And yeah, it's a really tricky environment. Yeah, absolutely.
And then there's one expression when you read about the moon, regolith. What is that?
Yeah, that's a good question. So we also have regolith here on Earth. Often we just call it soil. The way it's sort of defined on the moon is it's all of the broken up rocks and other small particles that sit on top of what we call the bedrock. So sort of the intact rock that was laid down from old volcanoes on the lunar surface. And the regolith itself is quite different from here on Earth just because of the way that it's formed. Back to this idea of not having any atmosphere. The moon is constantly bombarded by micrometeorites, and Earth is as well, but they burn up in our atmosphere. On the moon, that doesn't happen, so they impact, and these things can be small pebbles, but they hit with a lot of energy and sort of obliterate or pulverize whatever is on the surface of the moon at that time. And so you get all kinds of interesting structures that show up in the, let's say, regolith that we don't get here on Earth either. It's very similar to the surface layer of the Earth here, but it's a bit different in terms of how it's been created and how it weathers over time.
But when Armstrong and the rest of the crew on the Apollo 11 mission landed, how much did they know in beforehand?
I would say they didn't know a whole lot, actually. I mean, we have ideas of what we thought was up there. A lot of it turned out to be true. Lots of rocks and dust particles and soil particles that are derived from volcanic rocks, similar to what we have here on Earth. But I think the other interesting thing on the moon is that it doesn't have the same gravity as here on Earth. And so as Luke was talking about, they were falling down and it was hard to shovel or hard to dig rakes in. Gravity has a big influence on how all these materials behave. And so I think when they got off, I don't think any one of them knew what it was going to feel like to actually walk around and try to maneuver, even when they did these underwater experiments or practices where they used water and to try and reduce the effect of gravity. It's still a very strange sensation, I would think.
Yeah, and I think the dust as well was an issue they perhaps weren't prepared for, at least not to that extent, because it's very fine, very light particles, no humidity, so the electrostatic forces are pretty strong, and so it just gets everywhere, sticks to everything, gets into equipment. So yeah, that was an issue, and I think that's another topic of research now, how to mitigate this the effect of dust.
They must have been pretty brave coming to.
I think so. Yeah, for sure. Yeah, absolutely. Yeah.
But today NASA work to do the new moon expeditions, the Artemis. And this time the plan is to establish a more permanent habitable basis for more long-term expeditions. So to do so, why is knowledge of the lunar soil, the so-called regolith, so important, Luke?
Yeah, so it's really exciting because we're seeing with these Artemis missions, it's kind of the beginning of this sustainable and maybe even like permanent development of the lunar surface. And we know that on Earth, we do a lot of work to understand the mechanical properties of the subsurface and surface. So we can build on it, we can interact with it, we can drive on roads and railways and things, and these kind of things will apply as well to the moon. So firstly, for like structures, they need to be stable. We need to have a good performance, and this depends on our knowledge of the lunar soil, like its strength, stiffness, compressibility, and things we can measure in the lab and in the field. So we need to understand how they kind of behave when we're kind of interacting with it. This can be like for structures or vehicles and things. And at the same time, we need to be able to be using this soil as a resource. We need to extract things like water and oxygen, so that we can sustain like ourselves on the moon, and we can do things like create rocket fuel and things like this, which are going to be essential if we want to actually have a long-term base on the moon. So we need to understand the properties when we're talking about like excavating this material. So how easy is it to excavate? How easy is it to drill into? We need to be able to know the properties. So for mining systems to actually extract the materials and minerals and things that we need. and understanding as well. Like, I mean, we've only been really to kind of the drier parts, or the at least not to the poles where we have this water ice. And so we need to understand a lot more about that. So I think geotechnical engineering can play a key role in understanding the properties of the icy regolith and how we can extract water from that.
Yeah, because what you're saying is that on the moon you have polars, and there you also have ice.
Yeah, you tend to have this migration of water ice, which kind of accumulates at the poles within like craters, and especially in these like permanently shadowed regions. And these are the, especially in the South Pole right now, these are the kind of targets for these missions and for future development. Yeah.
But here on Earth, geotechnics is the study of soil properties in terms of, for instance, construction technology and the assessment of slope stability and the risk of landslides. So Dylan, can you say a bit about what are the parallels between NGI's knowledge base on geotechnics and the study of how lunar soils behave, what I know called selenotechnics?
I think that NGI is positioned very well to work in this field of lunar geotechnics or selenotechnics for a handful of reasons, but three come to mind. And I think the first one is when we go out, let's say through the design process, the first thing that we do is we sort of go out and survey the area, and we look at what the geology is on the surface, how things have changed through time, where things have been deposited. Quick clay is a big example in Norway of something that's hazardous that we have deposited all around. But NGI has a lot of expertise in going out and doing that initial survey to sort of lay out what does the subsurface look like. We do that with geophysics, and we do that with geotechnical data collection methods. Often what we do then is identify interesting areas from that kind of data, and we actually go and take samples of those interesting areas and bring them back to the lab and analyze them. And so I think that's the second thing, is that NGI has a lot of really amazing laboratory capabilities when it comes to characterizing materials, specifically granular soil materials, and then also solid rocks. So we have those two things. And then I think the third thing that's important for all of the upcoming, let's say, planned ideas of things we want to build on the lunar surface is that a lot of modeling needs to take place. So we sort of, on Earth, we go out, we identify an area, we want to build something, we test the material that's there, and then we come back and we model whatever our building or our structure is going to look like and how it's going to interact with the local geology and the local soils. And so NGI also has some really advanced modeling capabilities, both for onshore, but also for offshore, because we also do a lot of interesting things offshore, as maybe some past guests have talked about. And that's an even more challenging environment because the pressures and everything gets really crazy in deep water or even shallow water.
So more challenging than the environment on the moon.
Challenging in a different way, I would say. but it's forced us to be very innovative here at NGI, and I think that's why we're in a good spot to do this stuff on the moon too. Yeah.
So then can both of you tell me a bit on how has NGI then approached the task of analyzing the ground conditions on the moon? I've heard that you have had 10,000 particles from the Apollo expeditions.
Yeah. We do. We don't actually have the physical samples, but we have what's called nano CT scans. So very similar if you were getting a CT scan in a hospital. We collect that same kind of data on rocks and on soils to try to build up 3D models of the particles. To get back maybe one step ahead, how we've been addressing that here at NGI and how most of the world actually does this research is with what we call lunar simulants. So we take rocks that we find here on Earth that we think are kind of similar in terms of their mineralogy and their chemistry, and we try to manufacture soils or regolith that matches what the Apollo and the Luna missions brought back in the 70s. And what we end up doing in the lab here, because simulant is much cheaper, is we will run those through all kinds of our tests that we often do with normal materials here on Earth. What we have been able to do with these 10,000 Apollo samples is take those from the CT images and turn them into 3D numerical models where we can simulate the lunar environment, where we can make no pressure, we can reduce the gravity. It's about 1/6 on the moon of what we have for gravity here on Earth. And so we're trying to take what we learn from simulants by physically testing them in the lab, and then apply those to a simulated numerical model of the actual Apollo grains.
But how did you actually create here in the NGI lab an environment where you have the low gravity that you have on the moon?
Good question. We haven't done that yet. So there's only certain things that we can replicate here in the lab. So we can go to pretty low pressures. We still can't get quite as low. These are areas of research that everybody is struggling with, and there's big initiatives across Europe and in other countries to build these things called dirty vacuum chambers, where you can have dust floating around at almost zero atmospheric pressure. But for other things, maybe Luke can talk more about it. We are able to freeze samples. We can dry them out. But the gravity, that's a tricky one.
So that's one of the most difficult things.
Yeah, so I think the approach we're taking is really to apply the kind of standardized testing that we do at NGI, this kind of large scale testing. And at the same time, we want to calibrate this to the kind of one-off experiments that you can do in these vacuum chambers or on parabolic flights and things where you can get the low gravity. So we're going to take like a kind of combined approach and then kind of tie it all together with the numerical modeling. So if our numerical models can predict the behavior as we measure it in the lab, and also as we measure it on a parabolic flight or in a vacuum, for example, then we can just tune our numerical model to account for other things like the electrostatic forces that we expect to have on the moon, like thermal temperature changes and these kind of things. So we really want to rely on our kind of expertise and like using standards, like approaches which are repeatable and could be done by other labs as well, and so we can compare results. And at the same time, we kind of tie in these really advanced experiments, which are more expensive and we can do fewer times. But both are important, I think, and that's the kind of approach we want to take. Yeah.
Can you say some of the things that you have found out through these tests that you have done so far?
Yeah, I think that, one of the key things that this numerical modeling has allowed us is to look into really the shape of the particles that we're studying. So typically for these kind of models, you'd often use spheres, which are kind of like some equivalent size to the particles you want to study. And for a lot of things on Earth, that's fine because we have erosion and rivers and wind and things which round off the particles. But on the moon, it's not the case. And so everything's very sharp, very angular, elongated. So it's quite a challenge. And what we're seeing when we take these CT scans, these numerical models, which are basically following the same shape as the particles, the actual particles, for example, for the Apollo missions, is that firstly, these particles are quite different to anything we have on Earth. And also that they behave differently when we kind of have these simulations, and they can be more cohesive, or when they're sheared, they kind of dilate more. So there's kind of more pore space. It's quite different behavior to what we have on Earth, and we really need to take this into account when we're measuring properties, but also when we're designing experiments and things as well. It's quite important. Yeah.
But if then humans are to live and work on the moon for extended periods, it will not be possible to transport all vital resources such as water and energy and food. And I know that knowledge about the resources found on the moon, you mentioned it initially, and how these can best be utilized is important, the so-called ISRU, in situ resource utilization. Can you say a bit about how the Norwegian knowledge communities and industry contribute to developing knowledges and technology to solve these challenges? Can you say a bit about that, Luke?
Yeah, sure. Dylan, just jump in as well if I missed something out.
Yeah.
But Norway has a long history, a successful history when it comes to using Earth resources. We can think about, of course, like petroleum exploration and production, like offshore Norway, but of course there's mining and tunneling and things as well. So these are all very relevant to ISRU, how we manage resources, what we're talking about resources, and then like exploration, and then the different kind of stages when we go from a potential resource to something we can actually generate, produce what we want from it. And so we have kind of expertise throughout these value chains. And then there are kind of more specific Norwegian institutions as well, like NTNU are looking at growing plants and into space conditions. We have the Center for Interdisciplinary Research in Space as well, who are kind of launching things off the Earth's surface. For example, the Andøya Space launch site. And then we have things like startups, like making smart gloves for spacesuits, like Intention. And so there are lots of, of different size, lots of expertise from very large companies like Equinor and other things that have very relevant experience if they so wished, to very specific startups focusing on key aspects of space development and ISRU. Yeah,
I would guess that people wouldn't think that here in Norway we have expertise relevant for surviving on the moon. Were you surprised when you found out how much expertise there actually is?
I think the interesting thing. I've only been in Norway for a short while, but it's actually a fairly extreme environment if you compare it to other places that people might live on Earth. So I think, especially up in the Arctic, there's quite a bit of knowledge that goes into not just how do we live up there, but how do we make it, let's say, a nice environment to work? How do we utilize the landscape in terms of natural resources? Those are tough challenges in this. We have a short summer here. We have long winters, similar to the long nights on the lunar surface. So I think, there's a lot of untapped knowledge that can be used for that kind of stuff. And then, as Luke said, there's also a very strong technology industry in Norway. And there's a lot of, whether it be hardware or software, that needs to be created for all kinds of applications in space. There's lots of talent here in Norway. And as Luke said, there's already some startups and small things that are doing cool stuff.
And I understand that one recent result from the Norwegian expertise is a system that will make it possible to produce food on the moon. So can you, Dylan, tell us a bit about this study?
Yeah, definitely. So we're actually kicking that study off next month. But it's funded through ESA, the European Space Agency, and it's a partnership between a lab at NTNU, which Luke mentioned, CIRRUS, which is the Center for Interdisciplinary Research in Space, as well as NGI, and then as well as one of these startups called Solstice Mining. And I can't say so much about it because we haven't started the research yet, but the idea is to investigate the nutrients that are contained in the rocks on the lunar surface. So I think lots of people here know plants grow in soil. They need water, they need sunlight, and they need CO2, but they also need all the nutrients that they extract from the rocks and the grains that are in the soil. So we're going to try to, over the next year, look at these simulants and compare them to what we know about what nutrients actually exist on the moon. And then try to see if we can create some kind of, I can't say too much, but something that'll allow plants to grow. Let me put it that way.
It sounds like a possible new podcast episode.
It could be. Come back next year.
So according to NASA, the 2030s will be the decade for long-term settlement on the moon and potentially Mars as well. And the first launch, Artemis 1, took place on November 16 last year. And the spacecraft returned on December 30th. And this was an unmanned aircraft preparing to send humans to the moon. And I know that you both follow news from the Artemis program closely. What do you think there will be established village in space in 10, 15 years? And to do so, what are the biggest challenges that we have to be solved to ensure that this is safe?
Yeah, so I'm definitely more on the moon side rather than the Mars side. I think for the moon we can definitely imagine some more longer term developments. But I mean that's something that would still be new, even if we have the Apollo missions. This longer term development is something different. I mentioned just dust is a problem, and there's a focus group at Johns Hopkins University were dedicated to just dust mitigation. Sorry, so this is a key challenge that we see that's kind of quite relevant to NGI perhaps.
Because there is so much dust.
Yeah, it's just a problem for equipment, for getting into the astronauts' lungs and things, and it's so that's an issue related to the surface itself. But then you have all the kind of the medical challenges, like living in reduced gravity for long periods of time, and the radiation that's bombarding the surface as well. So there are lots of people thinking about what kind of structures do you need to protect from this and from impacts and things.
How long periods are we talking about? I've only read long term, but long term is a wide
That's a good question. I don't know, actually. I mean, long term, there's two things to think about, I guess. One is the length of time that any one individual is going to spend up there, because like Luke just said, there's issues with, let's say, your bone density and how your body handles that low gravity. So it's not healthy to stay up there for too long. So when we talk about long-term settlements, I'm not sure if that means people going, people coming back, people being replaced like they do on the International Space Station. But I think ideally, in terms of the infrastructure that we put in, we want to build it once and then have it be there so that when we come back to it, it's just like we left it, and we can immediately start using it and not have to rebuild things.
And then if you go there and you turn sick, what do you do?
Yeah, I mean, these are questions that they're being answered now, and they've been looked into by there's like a working groups and like the UN and things looking into like the legal aspects in this, and yeah, what do you do in the case of an emergency? Do you have to, and how do you have to share your infrastructure, your life support of people who are also in trouble and things? And this is these are key problems. There needs to be a strong framework in place. Perhaps there is a...
Yeah, I don't know yet. I mean, they have discussions about this, right? So there's the law of the sea, and you're supposed to rescue someone that's in distress. I know that they definitely have committees, and they've come up with plans, I think. I don't know how solidified those are. But there is the idea there that if there's someone else around and there's emergencies, I think you're supposed to help out. But this is again, 10 years down the road, probably before anything like that ever comes up.
But who owned the resources on the moon?
That's another good question. I think, I mean, it's under discussion how you can, what you own, what you can also sell or purchase from others on the moon in terms of resources and things.
Those are questions that haven't been answered yet.
Yeah.
So you can go to some of the conferences that we go to, and you can have sessions that are a bunch of lawyers from different countries, and they're talking about what they need to write into these treaties. And there's already some outer space treaty and other things, but now that there's actually potentially, let's say, commercial groups that are going to the moon and doing things, not just national space agencies, it gets a little bit more tricky in terms of who regulates who. And what are sort of the demarcations, if there is so-called property or whatnot, where someone lands.
But so far we have only talked about America's space agency, NASA, but Europe, they have also have also space programs, European Space Agency, ESA. And according to them, some 250 missions to the moon are due to be launched over the next decade. Why is it important also for Europe to participate in this global space race?
Yeah, I mean, I think the first thing that comes to mind is just the technology development that happens at a very broad scale when you try to take on challenges like going to space and landing on the moon, for example. I think what's interesting, what Luke brought up before, is and you also, this idea of in situ resource utilization. Because we have limited resources on the moon, scientists and researchers are having to come up with very clever ways to do things that we do pretty commonly here on Earth. And so what's interesting is to think about, okay, if they're going to do that, are they going to come up with a way that's better than what we do on Earth? Are they going to come up with some way to produce food that's more efficient than what we do here on Earth? Are they going to change some processing pipeline that then reduce the cost to take raw goods and manufacture them into something usable for us? I mean, I think a lot of people know this, but maybe some don't. A lot of the, let's say, communication and navigation tools that you find in your pocket now every day in your cell phone, lots of that kind of technology comes out of these space programs. And so from the perspective of ESA, I think the EU is a big group that has a big population to serve. And we should be just thinking about where are we pushing the boundaries of technology? And who cares that it's going to the moon or doing something else like self-driving cars? But we should always be at the forefront so that we can benefit from those technologies when they actually do become developed.
Do you have anything to add, Luke?
Yeah, I mean, what Dylan says, exactly, I totally agree. I mean, we're seeing things like 3D printing using ceramics, which are kind of designed so they would work like on the moon, but then this also has implications for improvements on Earth. So I think that's really key, and one of the things I've noticed a lot just by attending these different conferences and things on in situ resource utilization is that it's not just it's an exciting period for researchers, but also for the startup community and things. There's funding from ESA, like via programs like Spaceship Program, when you have these really complex mission calls, when they need to get basically ideas for new technologies and developments that they can use in space, and these are so kind of complex and they need so many different disciplines that they're kind of bringing in students and young professionals like from across Europe to kind of tackle these challenges. And so with this kind of support for like startups, we see it as well at the European Space Resources Innovation Center in Luxembourg. And we'll be giving a talk there actually as well in a few weeks' time. And it's just really exciting to see all these startups and the funding that's available to them, also in Europe. Typically, this has been mostly in the US, but now it's growing as well in Europe. So it's very interesting to see.
And Norway, we have been member of ESA since 1987. We've already talked about in situ resource utilization, but are there other areas where Norwegian expert communities, including here at NGI, have knowledge that are relevant for ESA?
Yeah, I think we talked about maybe a little bit before, but some other things that come to mind, KSAT, Kongsberg. Norway has a long history of developing hardware that goes on satellites for Earth observation. So maybe in the past, all the stuff that we've put into space that Norway has participated in looks sort of down back to Earth. But that's been changing recently. We also have the SENSE Center here at the University of Oslo, which stands for Center for Space Sensing and Systems. They actually created what's called a ground penetrating radar system, RIMFAX, which is on Mars right now, exploring for life. So from the hardware side, Norway definitely has a long history of making satellite communications and imaging hardware. And I think that's going to be for sure something that we need forever. Mm-hmm. The further out into space we go, we're just going to need better and better communication, that kind of stuff. I think another thing that's interesting, one company that I don't think we mentioned yet, but Luke and I have become aware of, and we actually got to play with their technology, is a virtual reality company called Pale Blue, that is actually making a low gravity simulator so that you can practice what it's like to go work on the International Space Station or eventually go work on the moon. And so there's expertise, let's say, in what we would call visualization and virtual reality that is already in Norway for other reasons, but once in a while somebody learns about it and then they're also interested in space. So they say, I should apply this to space.
It sounds like you've already started to practice, because if you had the option, would you like to visit the moon and to see and study the landscape in real life? Let's start with you, Dylan.
Oh yeah, I would say definitely. I would be terrified for sure. But I think it would be a very cool experience to go up to the moon and not just look at the surface of the moon, but also to look back at Earth. Still, there's not that many people that have had that experience, and I think it would be pretty cool.
What about you, Luke?
Yeah, I would have to say yes, of course, but equally terrified. But I think it'd be just so exciting just to kind of see the Earth looking. The Apollo missions some time ago now. Many people have been born since then who haven't seen this. So I think it's going to be a special moment when we have our kind of first live streams coming back to Earth and we kind of realize how special it is down here.
Thank you, both of you. It will be very exciting to follow both the Artemis expedition and the European Space Agency, ESA, in the years to come. And what's sure is that these expeditions will be far better prepared than Neil Armstrong and his comrade Edwin Buzz Aldrin when they landed in 1969. They only spent 2 hours and 36 minutes on the moon, collecting 22 kilograms of material from the surface. Thanks a lot to both of you for telling us how these samples have been used and are now used in planning of future and more long-term settlements on the moon, and for providing these updates on some of the ongoing exciting work related to space in NASA, ESA, and even in the laboratory here at NGI. If you're interested in hearing more about the exciting work that NGI's researchers work with, you find more episodes here at Med blikket mot bakken. And I will also recommend our English-speaking podcast, where experts talk to and with other experts, NGI Technical. But for now, from Earth, bye now.